Hi, I'm Curt Breneman, Dean of the School of Science, and I'd like to welcome you to a Rensselaer Moment of Science. I'm standing here in front of AiMOS, which is actually the fastest supercomputer at a private university. And I'm talking to you today because I want to talk about how that machine is used along with others to get the best artificial intelligence modeling of the COVID pandemic. When artificial intelligence models are created, they use a lot of data and they expose the modeling method to a lot of evolving data. And by using those methodologies, we're able to capture what's going on actually inside of all of that data. For example, within a community, why is COVID spreading? How do we create policies that'll mitigate that? And then how do we keep it down in the future so that we don't have to go through closures like this? The policies that could come from this would be such things as how many people can be in a room of a given size? How much personal protective equipment do we need? For example, how many people can share a restroom in a res hall? These sorts of things were developed actually in order to be able to reopen universities, other organizations, and it scales with the size of the community. What we do know is that one size does not fit all when it comes to policies and models. One community is not like another, but data-driven approaches and evolving AI approaches to the problem can solve them even in those disparate situations like that. So what I wanted to do was to say that, for example, if we have a particular amount of transmissibility that's going on in a population, we may not know what that is or where it comes from. But examining the AI models, once they're made and as they evolve, we can tell what's generally pushing something in one direction or another, and how the effects that we then propose would have influenced that pandemic, ultimately allowing it to keep the numbers of infections way down. Thank you so much for joining us for a Rensselaer Moment of Science. We look forward to seeing you in the next episode.